For a long, long time, the idea of a conscious machine has been pure science fiction, right? But what if we took that idea out of the movies and put it right into the engineering lab? Well, that's what we're going to do. We're going to dive into a blueprint for how we might actually build a self-aware machine.
This is the big one. It's a question that philosophers have been wrestling with for centuries. But now, something's different. Engineers are looking at this as a real, concrete design problem. We're not just asking, what is consciousness anymore? We're asking, how do you build it?
Okay, so before we can even start talking about building something like this, we have to wrap our heads around the scale of the challenge. And with consciousness, well, the challenge is absolutely profound. It is one of the biggest mysteries out there.
That's right. For the longest time, this was something only philosophers and sci-fi writers worried about. But what's changed is that scientists and engineers are now taking it seriously. They're working from the idea that consciousness isn't some kind of magic. It's a physical process that, at least in theory, can be understood and maybe even replicated.
So here's the thing. If you're going to build anything, you need a blueprint. And that starts with defining our terms. What are we actually trying to create? Because it's really easy to mix up ideas like autonomy, intelligence, and consciousness, but they are very, very different concepts.
First up, autonomy. All this really means is that a system can function on its own. Think of an earthworm. It's totally autonomous. It finds food, it avoids danger, nobody is controlling it with a joystick, but you wouldn't exactly call it intelligent or self-aware.
Next, you've got intelligence. Now, this is all about problem solving and learning. A supercomputer that can crush a chess grandmaster is obviously incredibly intelligent, but it's not autonomous. It can't get up and plug itself into the wall, and it certainly isn't conscious.
And that brings us to the main event, consciousness. Now, for an engineer, we're not getting lost in some deep philosophical rabbit hole. We're talking about something we can actually try to measure, sometimes called access consciousness. And really, it's just a state of self-awareness. It's the ability to know that you exist.
So to break that self-awareness down, any conscious system would need to have three key things. First is subjectivity. That's the fact that your inner world, your thoughts, your feelings is totally private and unique to you. Second is unity, which means you don't experience sight and sound and touch as separate things. Your brain just seamlessly weaves them all into one single reality. And finally, there's intentionality. This just means your thoughts are always about something. You're not just thinking, you're thinking about a project or a friend or what you want for lunch.
So, how can we even test for this? Well, one classic method is the mirror test. It's pretty simple. You put a little mark on an animal's face where they can't see it. If they look in a mirror and touch the mark on their own body instead of on the mirror, it suggests they recognize themselves. Great apes, dolphins, elephants, and get this, even magpies can pass this test.
Okay, so if we're serious about building a conscious machine, where on earth do we get the plans? Well, we study the only working model that we have, the human brain. The whole goal becomes to try and reverse engineer its most important functions.
And that is not a simple task. Just look at this number. That's 100 trillion synapses, the little connections between neurons. And that's just in the human cortex. The sheer scale and complexity of the brain it's just mind-boggling.
This quote right here, it really gets to the core of the whole engineering approach. The main assumption is what's called materialism, the idea that the mind isn't some separate, mystical thing. No, it's a product of the physical brain. It's a process. And if it's a process, then it can be replicated.
But here's what's so fascinating. Most of the brain's work happens unconsciously. Think about a professional baseball player at the plate. He doesn't have time to consciously think about every part of his swing. After thousands and thousands of hours of practice, that skill is handled by what some neuroscientists call zombie agents. These are highly trained, automatic, unconscious routines.
So, we've got our target, the brain, and we know its key attributes. Now for the big question, how do we actually build it? This is where we run into some massive hardware and software challenges.
If you look at just raw processing power, it's pretty amazing. Our best supercomputers are actually getting into the same ballpark as the human brain. But, as you can see here, pure speed and memory, that's only a tiny part of the story.
Because here's the real kicker: efficiency. Your brain does all that incredible work using just 20 watts of power. That's about enough to run a dim light bulb. A supercomputer that can even come close needs megawatts of power and fills an entire room. We're talking 5 to 7 times orders of magnitude less efficient. It's not even close.
And the differences go way deeper than just power. The brain is an analog device. It's massively parallel, and it literally learns and rewires itself as it goes. A computer is digital, it's mostly serial, doing one thing at a time, and it just follows a fixed program. So we're not just trying to build a faster computer, we need a fundamentally different kind of architecture.
So what would that new architecture actually look like? Well, this blueprint here proposes a sort of hybrid approach. At the bottom layer, you've got systems that act like our senses, processing raw data from cameras and mics. Then, way up at the top layer, you have systems for logic and planning. But the real magic is in the middle, creating this constant feedback loop that connects what the machine perceives with how it thinks.
But even if you get all the hardware and all the software right, there's one last, absolutely crucial idea we have to understand. You can't just program a machine to be conscious. It has to become conscious. And that brings us to this idea of emergence. See, consciousness isn't a feature you can install like an app on your phone. It's a property that emerges from a massively complex system, with all those sensors and processing layers interacting with its environment over a long period of time. This is exactly how it works for us. A newborn baby isn't self-aware at birth. Consciousness develops over time. It emerges as the brain grows and learns and builds a model of the world, and, crucially, a model of itself inside that world. A machine would have to do the exact same thing. It would have to learn, basically, like an infant. And all of this leaves us with a final, really provocative thought. If consciousness isn't some unique, magical spark that only we have, but instead it's an emergent property of complexity, something that can, in principle, be engineered, what does that say about our own place in the universe? What does it really, truly mean to be human?